Dinosaurs, giants of a lost world that ruled the Earth for millions of years. From terrifying apex predators like the mighty Tyrannosaurus rex to the awe-inspiring giants like Brachiosaurus, these prehistoric creatures continue to capture our imaginations. But which ones truly stand out as legends of the dinosaur age? In this video we're counting down the top 14 most legendary dinosaurs of all time, those that left an indelible mark on history and remain icons of the Mesozoic era. From ferocious hunters to gentle giants, prepare to uncover the incredible stories behind the most fascinating dinosaurs ever discovered. Get ready to step back in time, because this is a journey you don't want to miss. Tyrannosaurs, kings of the Cretaceous. Characteristics: apex predators of the Mesozoic. Tyrannosaurs were among the most formidable carnivorous dinosaurs to ever roam the Earth. Known for their massive size, powerful jaws, and sharp teeth, these theropods were the apex predators of their ecosystems. Most members of the Tyrannosaur family had robust skulls, muscular hind limbs, and small, seemingly disproportionate forearms, which were nevertheless powerful and capable of assisting in prey capture. Their teeth, shaped like bananas, were serrated for slicing through flesh and crushing bone, enabling them to hunt and consume large prey. Standing up to 4 meters tall at the hip and measuring up to 12 meters in length, these dinosaurs could weigh over 9 tons. Despite their size, studies suggest they were capable of short bursts of speed, making them highly efficient hunters. Their keen sense of smell, vision, and hearing gave them a significant advantage as top predators. Notable species: Tyrannosaurus rex, T-Rex. The most famous member of the Tyrannosaur group, Tyrannosaurus rex, is often referred to as the king of the dinosaurs. Its name, meaning tyrant lizard king, reflects its dominance during the late Cretaceous period. T-Rex could grow up to 12 meters long and was equipped with a skull over 1.5 meters in length. Its bite force, estimated at over 5,800 kilograms, was one of the strongest of any terrestrial animal, allowing it to crush the bones of its prey with ease. Fossil evidence shows that T-Rex preyed on large herbivores such as Triceratops and Edmontosaurus and may have also scavenged when the opportunity arose. Habitat: rulers of Eurasia and North America. Tyrannosaurs thrived in the diverse habitats of the late Cretaceous, primarily in what is now North America and parts of Eurasia. Fossils have been found in regions ranging from the United States to Mongolia, indicating their adaptability to various climates, from lush forests to arid plains. Their dominance in these regions can be attributed to their evolutionary adaptations, which allowed them to hunt effectively, compete with other predators, and exploit a wide range of food sources. The tyrannosaurs, particularly Tyrannosaurus rex, symbolize the peak of predatory dinosaur evolution. Their unparalleled power, adaptability, and evolutionary success ensure their place as legends of the prehistoric world. Sauropods, giants of the Jurassic. Characteristics: icons of size and strength. Sauropods were among the largest animals to ever walk the Earth, characterized by their immense size, long necks, thick, barrel-shaped bodies, and elongated tails. These herbivorous dinosaurs evolved to dominate the plant-eating niche in prehistoric ecosystems, reaching lengths of up to 40 meters and weights exceeding 70 tons in some species. Their long necks allowed them to browse vegetation from tall trees, a feature that minimized competition with other herbivores feeding closer to the ground. Supported by lightweight, air-filled vertebrae, their necks were highly efficient for reaching food without requiring significant energy to move their massive bodies. Meanwhile, their strong, muscular tails served as a counterbalance and could be used as a defensive weapon against predators. Sauropods had peg-like or spatulate teeth suited for stripping leaves but not chewing. Instead, they swallowed vegetation whole, relying on gastroliths and their massive digestive systems to process tough plant material. Notable species: Apatosaurus. Measuring up to 23 meters in length, Apatosaurus was a robust sauropod with a relatively short neck compared to other members of its group. Its name, meaning deceptive lizard, reflects early confusion about its classification. This dinosaur thrived in North America during the late Jurassic, grazing on loam to mid-level vegetation. Brachiosaurus. Known as the arm lizard due to its longer front legs compared to its hind legs, Brachiosaurus stood taller than most sauropods, reaching heights of up to 13 meters. This asymmetrical build allowed it to feed on vegetation at the highest tree canopies, avoiding competition with other herbivores. Brachiosaurus fossils have been found in both North America and Africa. Diplodocus, with a long whip-like tail and slender body, Diplodocus could grow up to 30 meters in length. Its low-slung neck was likely used for grazing on ferns and other ground vegetation. Fossils of Diplodocus are among the most complete sauropod remains ever found, providing extensive insight into its anatomy and lifestyle. Habitat: thriving in the Jurassic world. Sauropods were primarily dominant during the Jurassic period, around 200 to 145 million years ago, although some species persisted into the Cretaceous. They inhabited a variety of environments, including floodplains, forests, and open plains, thriving in warm climates with abundant vegetation. These herbivores often lived in herds, which provided protection against predators such as Allosaurus and Ceratosaurus. Fossilized trackways suggest that sauropods may have migrated seasonally in search of food, traversing vast distances to sustain their enormous appetites. The sauropods represent the pinnacle of size and adaptability in the dinosaur kingdom. Their iconic long necks, immense strength, and evolutionary success ensure their lasting legacy as the gentle giants of the Jurassic. 3. Ceratopsians, the horned dinosaurs. Characteristics: iconic skulls and defensive features. Ceratopsians are among the most recognizable dinosaurs, known for their large, elaborately shaped skulls adorned with horns and frills. These herbivorous dinosaurs, often compared in size to modern elephants, displayed remarkable diversity in horn configurations and frill designs. Their frills, which extended backward from the skull, could be solid or perforated with openings, serving multiple potential purposes such as defense, thermoregulation, or species recognition. Their horns varied greatly among species, ranging from the prominent three-horned configuration of Triceratops to the five horns of Pentaceratops. These features likely played a role in defending against predators like Tyrannosaurus rex and may have been used for mating displays or dominance battles within their herds. Ceratopsians had strong beaks suited for cropping tough vegetation and dental batteries consisting of stacked teeth, which continuously replaced worn ones. This arrangement allowed them to efficiently grind fibrous plant material, making them highly effective grazers. Notable species: Triceratops. The most famous ceratopsian, Triceratops, lived during the late Cretaceous and measured up to 9 meters in length. Its iconic three horns and solid bony frill made it a formidable opponent against predators. Fossil evidence suggests that Triceratops may have used its horns in combat, both against predators and during interspecies confrontations. Its robust build and powerful jaws enabled it to consume a wide variety of vegetation, including cycads and palms. Pentaceratops. Known for its impressive five-horned face, Pentaceratops lived in North America during the late Cretaceous. It had one of the largest skulls of any land animal, measuring up to 3 meters long. This species likely inhabited forested environments and open plains, using its horns and frill for defense and display. Habitat: thriving in the Cretaceous. Ceratopsians thrived during the late Cretaceous period, approximately 100 to 66 million years ago, primarily in what is now North America and Asia. They lived in a variety of environments, from forested regions to open plains, often traveling in herds for protection against predators. The warm climate and abundant vegetation of the Cretaceous provided ideal conditions for ceratopsians to flourish. Their size and defensive features made them a critical component of their ecosystems, as they supported food chains by serving as prey for large carnivores while shaping vegetation patterns through their grazing habits. Ceratopsians remain some of the most fascinating dinosaurs due to their iconic skull designs, formidable defense mechanisms, and significant role in Cretaceous ecosystems. Their adaptability and evolutionary success highlight the incredible diversity of life during the Mesozoic era. Raptors, the agile predators. Characteristics: speed, intelligence, and deadly claws. Raptors, or dromaeosaurids, were small to medium-sized carnivorous dinosaurs renowned for their agility, intelligence, and predatory skills. These theropods were bipedal, with lightweight, slender bodies that allowed them to move quickly and maneuver with precision. One of their most distinctive features was the enlarged, sickle-shaped claw on the second toe of each foot, which was used to slash and grip prey. Raptors were highly intelligent compared to other dinosaurs, with evidence suggesting advanced hunting strategies and possible pack behavior. They possessed excellent vision and sharp teeth suited for tearing flesh, making them efficient and versatile hunters. Feathered bodies, as revealed by fossil evidence, suggest that raptors were closely related to modern birds. Feathers likely played a role in thermoregulation, display, or even aiding in stability and agility during hunts. Notable species: Velociraptor. Perhaps the most famous raptor, Velociraptor lived during the late Cretaceous period in what is now Mongolia. It measured about 2 meters long and weighed approximately 15 kilograms. Contrary to its portrayal in popular media, the Velociraptor was relatively small but exceptionally agile, using its sharp claws and teeth to hunt smaller prey or scavenge carcasses. Its fossilized remains often reveal evidence of fierce battles, including one famous specimen locked in combat with a Protoceratops. Deinonychus, a larger relative of Velociraptor, Deinonychus lived in North America during the early Cretaceous. Measuring up to 3 meters in length, it was a formidable predator known for its strong legs and powerful claws. Fossilized trackways suggest that Deinonychus may have hunted in packs, increasing its efficiency in taking down larger prey. Utahraptor, the largest known raptor, Utahraptor, lived during the early Cretaceous in North America. It could reach lengths of up to 7 meters and weigh over 500 kilograms. This raptor combined size with agility, making it one of the most dangerous predators of its time. Its sickle-shaped claw, measuring nearly 24 centimeters, was a powerful weapon for slashing prey. Habitat, evolutionary links to modern birds. Raptors lived during the Cretaceous period, inhabiting diverse environments ranging from arid deserts to dense forests. Their geographic range spanned continents such as North America, Asia, and Europe. Fossil evidence of feathers in raptors such as Velociraptor and Microraptor suggests a close evolutionary relationship with modern birds. This connection is supported by similarities in skeletal structures, such as the wishbone, furcula, and hollow bones. Raptors are a key example of the evolutionary transition from non-avian dinosaurs to avian species. Raptors, with their combination of speed, intelligence, and advanced hunting strategies, were among the most versatile predators of the Mesozoic era. Their agility and adaptability allowed them to thrive in competitive ecosystems, leaving behind a legacy as one of the most dynamic and bird-like dinosaur groups. Theropods, the fierce two-legged predators. Characteristics: carnivorous and agile hunters. Theropods were a diverse group of bipedal carnivorous dinosaurs that thrived across the Mesozoic era, from the late Triassic to the end of the Cretaceous period. The name theropod means beast foot, referring to their three-toed limbs that supported swift and agile movement. These dinosaurs were primarily meat-eaters, although later species displayed omnivorous and even herbivorous tendencies. Key characteristics of theropods include sharp, serrated teeth for slicing flesh, strong jaws, and muscular legs that allowed for efficient locomotion. Many theropods also had hollow bones, reducing weight and enhancing speed and agility. Their claws and keen eyesight made them effective predators, capable of taking down prey with precision. Theropods are notable for their evolutionary link to modern birds, as evidenced by fossilized remains showing feathers and bird-like skeletal structures in many species. This group includes some of the most iconic and feared dinosaurs, such as Tyrannosaurus rex, Velociraptor, and Allosaurus. Notable species: Allosaurus, a dominant predator of the late Jurassic. Allosaurus measured up to 10 meters in length and weighed around 2.5 tons. Known for its sharp claws and serrated teeth, it hunted large herbivores like Stegosaurus and Diplodocus. Fossil evidence suggests it may have hunted in packs, making it a formidable force in Jurassic ecosystems. Megalosaurus, one of the first dinosaurs ever discovered and scientifically named, Megalosaurus lived during the Middle Jurassic in Europe. It measured about 9 meters in length and had strong jaws for crushing bones. As one of the earliest theropods studied, Megalosaurus paved the way for understanding dinosaur evolution. Tyrannosaurus rex, although highlighted in the Tyrannosaur section, T-Rex remains one of the largest and most iconic theropods, with unparalleled hunting capabilities and an apex position in late Cretaceous ecosystems. Habitat, spanning the Mesozoic era. Theropods were widespread, thriving in a variety of environments from the late Triassic to the end of the Cretaceous, approximately 230 to 66 million years ago. Their fossils have been found on every continent, indicating their adaptability to different climates, from arid deserts to tropical forests. The geographic and temporal range of theropods allowed for extraordinary diversity within the group, from the small, feathered Microraptor to the massive Spinosaurus, which adapted to semi-aquatic life. Theropods represent one of the most dynamic and influential groups of dinosaurs, dominating terrestrial ecosystems for over 160 million years. Their legacy endures through their evolutionary descendants, modern birds, ensuring their continued impact on Earth's history. Titanosaurs, the armored giants of the Cretaceous. Characteristics: herbivorous titans with armored skin. Titanosaurs were the last and largest group of sauropods, thriving during the late Cretaceous period. These massive herbivorous dinosaurs were characterized by their long necks, bulky bodies, and whip-like tails, but what set them apart was their tough, armored skin. Fossilized remains of titanosaurs often show evidence of bony plates, known as osteoderms, embedded in their skin, providing protection against predators. Ranging from 12 to over 40 meters in length and weighing up to 70 tons, titanosaurs were true giants of their time. Despite their immense size, they had relatively small heads and peg-like teeth, suited for stripping vegetation such as ferns, cycads, and conifers. Their immense digestive systems allowed them to process large quantities of low-nutrition plant material, sustaining their colossal frames. Unlike earlier sauropods like Apatosaurus or Diplodocus, titanosaurs displayed greater adaptability, thriving in diverse environments, including floodplains and forested regions. Habitat: replacing ancient sauropods. Titanosaurs emerged during the late Cretaceous, around 100 to 66 million years ago, replacing earlier sauropods such as Apatosaurus. They were widespread, with fossil evidence found on every continent, including Antarctica, indicating their ability to adapt to varied climates and ecosystems. The fragmentation of Pangaea during the Cretaceous created isolated landmasses, leading to the evolution of distinct titanosaur species across different regions. In South America, for example, Argentinosaurus became one of the largest dinosaurs ever discovered, while Dreadnoughtus and Saltosaurus thrived in similar habitats. In Africa and Asia, titanosaurs like Paralititan and Rapidosaurus dominated local ecosystems. Titanosaurs likely lived in herds, a behavior that offered protection against predators such as Tyrannosaurus rex and Carnotaurus. Their size and armor made them difficult targets, deterring all but the most determined carnivores, a legacy of resilience and adaptation. Titanosaurs represent the culmination of sauropod evolution, showcasing remarkable adaptations that allowed them to flourish in the changing ecosystems of the late Cretaceous. Their tough skin, massive size, and dietary versatility ensured their dominance until the mass extinction event that marked the end of the Cretaceous period. As some of the last giants to walk the Earth, titanosaurs embody the resilience and adaptability that defined the Age of Dinosaurs. Their fossils continue to offer valuable insights into the biology and behavior of these extraordinary creatures, securing their place as legendary icons of the prehistoric world. Ankylosaurus, the armored tank of the Cretaceous. Characteristics: nature's living fortress. Ankylosaurus was one of the most heavily armored dinosaurs of the Cretaceous period, often referred to as a living tank. Measuring up to 10 meters in length and weighing around 4 tons, this herbivorous dinosaur was built for defense. Its body was covered with bony plates, called osteoderms, forming a tough, protective shell that deterred even the fiercest predators. Sharp spikes lined its body, providing an additional layer of defense against attacks from carnivores like Tyrannosaurus rex. The Ankylosaurus also wielded a unique and powerful weapon, a large, club-like tail. This bony mass at the end of its tail could deliver devastating blows, strong enough to break the bones of attacking predators. Combined with its low, squat body and heavily armored head, Ankylosaurus was nearly impervious to attacks, prioritizing defense over speed. Despite its heavily armored exterior, Ankylosaurus had relatively small teeth, adapted for chewing soft vegetation. It primarily fed on low-lying plants such as ferns and cycads, relying on its robust digestive system to process tough, fibrous materials. Habitat: thriving in the Cretaceous world. Ankylosaurus lived during the late Cretaceous period, approximately 68 to 66 million years ago, in what is now North America. Fossil evidence indicates that these dinosaurs inhabited forested floodplains and open grasslands, areas rich in low-lying vegetation that suited their grazing habits. The warm, stable climates of the Cretaceous, coupled with the proliferation of flowering plants, created an ideal environment for herbivorous dinosaurs like Ankylosaurus. Its defensive adaptations allowed it to coexist with formidable predators, filling a crucial role in the ecosystem. A master of defense, Ankylosaurus epitomizes the pinnacle of defensive evolution among dinosaurs. Its heavily armored body, sharp spikes, and tail club made it a nearly invincible target for predators. Unlike other herbivores that relied on speed or size for survival, Ankylosaurus stood its ground, using its defenses to ward off even the most determined attackers. The legacy of Ankylosaurus lies in its unique combination of resilience and adaptability. As one of the last armored dinosaurs before the mass extinction event at the end of the Cretaceous, It serves as a testament to the diversity and innovation of prehistoric life. Feathered dinosaurs, the prehistoric precursors to birds. Characteristics: feathered evolution. Feathered dinosaurs represent a significant evolutionary bridge between traditional reptiles and modern birds. These dinosaurs were theropods, a group that includes iconic species like Velociraptor and Tyrannosaurus rex. Unlike earlier depictions of dinosaurs as exclusively scaly creatures, fossil evidence has revealed that many theropods were covered in feathers, ranging from simple down-like structures to complex flight feathers. Feathers served multiple purposes. For smaller species, they likely provided insulation to regulate body temperature, while for larger species, they may have been used for display or courtship. Some feathered dinosaurs even developed adaptations for gliding or powered flight, showcasing a gradual evolutionary transition to avian species. Notable species: Sinornithosaurus. One of the most well-known feathered dinosaurs is Sinornithosaurus, a small, bird-like theropod that lived during the early Cretaceous in what is now China. Measuring about 1 meter in length, it was covered in feathers and exhibited many traits associated with early avian evolution. Fossils of Sinornithosaurus reveal a lightweight skeletal structure and sharp, serrated teeth, suggesting it was a carnivorous predator. Its feathers may have aided in maneuverability, allowing it to leap between trees or glide short distances in pursuit of prey. Sinornithosaurus represents a critical link in understanding how flight evolved from terrestrial theropods. Habitat: thriving in diverse environments. Feathered dinosaurs lived during both the Jurassic and Cretaceous periods, inhabiting a variety of environments from dense forests to open plains. Fossil evidence of feathered dinosaurs has been predominantly found in Asia, particularly in regions like Liaoning Province in China, where exceptional preservation conditions have revealed intricate feather impressions. These environments provided abundant opportunities for these small to medium-sized predators to thrive. Forests offered cover for ambushing prey, while feathered limbs and tails helped them climb trees or leap into the air. Legacy: the birth of birds. Feathered dinosaurs are crucial to understanding the evolutionary connection between non-avian dinosaurs and birds. Species like Archaeopteryx, with their blend of reptilian and avian traits, highlight this transition. Modern birds inherit features such as feathers, hollow bones, and wishbones from their dinosaur ancestors. Feathered dinosaurs not only redefined the scientific understanding of dinosaurs but also demonstrated the incredible adaptability and innovation of life during the Mesozoic era. They remain a fascinating testament to evolution, bridging the gap between the ancient past and the living world today. Therizinosaurus, the clawed enigma of the Cretaceous. Characteristics: long claws and unusual anatomy. Therizinosaurus, one of the most bizarre dinosaurs of the Cretaceous period, is easily recognized by its exceptionally long claws. These claws, measuring up to 1 meter in length, are the longest known in any terrestrial animal. Despite its fearsome appearance, Therizinosaurus was primarily herbivorous, using its claws to pull down branches and gather vegetation. However, some paleontologists theorize it may have been omnivorous, occasionally feeding on small animals or scavenging. This dinosaur had a unique body structure with a small skull, long neck, and robust, barrel-shaped torso. It stood on 2 legs and could reach lengths of up to 10 meters, weighing approximately 5 tons. Its teeth were adapted for processing plant material, indicating a diet of leaves, fruits, and other vegetation. Therizinosaurus likely moved slowly due to its bulky frame and relied on its intimidating claws and size to deter predators. Its feathers, evidenced by fossilized relatives like Bipiosaurus, may have served for insulation or display. Habitat: Cretaceous forests and plains. Living approximately 70 million years ago during the late Cretaceous, Therizinosaurus inhabited regions of what is now Asia, particularly Mongolia. Fossils suggest it thrived in forested environments and open plains, where it could forage for vegetation. The warm, humid climate of the late Cretaceous, combined with abundant plant life, created an ideal habitat for herbivorous dinosaurs like Therizinosaurus. Its claws may have allowed it to exploit food sources inaccessible to other herbivores, such as high branches or thick vegetation. A mystery in behavior and diet. The discovery of Therizinosaurus puzzled paleontologists for decades. Initially, its massive claws were thought to belong to a giant turtle until more complete fossils revealed its unusual anatomy. Its mix of herbivorous and potentially omnivorous traits sets it apart from other theropods, challenging traditional classifications. A symbol of evolutionary creativity, Therizinosaurus stands as a testament to the diversity of dinosaur adaptations during the Cretaceous. Its unique combination of long claws, herbivorous diet, and feathered body highlights the innovative evolutionary paths that dinosaurs explored. As one of the most peculiar and fascinating creatures of the prehistoric world, Therizinosaurus continues to captivate both scientists and enthusiasts alike. Stegosaurus, the plated icon of the Jurassic. Characteristics: bony plates and defensive spikes. Stegosaurus, one of the most iconic dinosaurs of the Jurassic period, is easily recognized by the large, bony plates that adorned its back and the sharp spikes on its tail. Measuring up to 9 meters in length and weighing around 4 tons, Stegosaurus was a slow-moving herbivore, but its unique physical features made it a formidable presence in its environment. The bony plates, arranged in 2 alternating rows along its back, likely served multiple purposes. Thermoregulation. The plates contained a network of blood vessels, which may have helped the dinosaur regulate its body temperature by dissipating heat or absorbing solar energy. Display and communication. The plates could have been used to attract mates or intimidate predators and rivals through visual display. The tail, equipped with 4 sharp spikes known as a thagomizer, served as a powerful defensive weapon. Fossil evidence, including puncture wounds on predator bones, suggests that Stegosaurus used its tail to fend off large carnivores like Allosaurus. Despite its robust body, Stegosaurus had a remarkably small brain, about the size of a walnut, indicating relatively simple behavior and instincts. However, its physical adaptations compensated for any cognitive limitations, making it a well-adapted herbivore. Habitat: thriving in Jurassic landscapes. Stegosaurus lived approximately 155 to 150 million years ago during the late Jurassic, primarily in North America and parts of Europe. Its habitat consisted of semi-arid plains, forests, and floodplains, where it grazed on low-lying vegetation such as ferns, cycads, and horsetails. The warm and stable climate of the Jurassic supported lush vegetation, providing ample food for herbivorous dinosaurs. Stegosaurus likely traveled in small groups, offering some level of protection against predators while foraging, an icon of adaptation. Stegosaurus symbolizes the innovative adaptations of herbivorous dinosaurs during the Jurassic. Its bony plates and spiked tail highlight the creative evolutionary strategies used for survival in a world dominated by massive predators. As one of the most studied and beloved dinosaurs, Stegosaurus remains an enduring figure in paleontology and popular culture, capturing imaginations with its distinctive appearance and fascinating adaptations. Pachycephalosaurus, the dome-headed dinosaur. Characteristics: thick-skulled fighters. Pachycephalosaurus, meaning thick-headed lizard, is best known for its distinctive dome-shaped skull, which could reach up to 25 centimeters in thickness. This herbivorous dinosaur lived during the late Cretaceous, approximately 70 to 66 million years ago, and was among the last non-avian dinosaurs before the mass extinction event. The dome-shaped skull of Pachycephalosaurus was surrounded by small bony knobs and ridges, giving it a unique appearance. Paleontologists believe this thick skull may have been used in headbutting contests, similar to modern-day rams or goats. Such behavior could have played a role in interspecies dominance displays, territorial disputes, or mate competition. Alternatively, the skull may have served as a defense mechanism, helping the dinosaur survive predator attacks. Standing around 4.5 meters long and weighing roughly 450 kilograms, Pachycephalosaurus was a bipedal dinosaur, moving on 2 strong legs. Its short forelimbs were not suited for grasping or climbing but may have been used for balance. Its teeth were small and serrated, ideal for chewing tough, fibrous vegetation such as leaves and fruits. Habitat: Cretaceous plains and forests. Pachycephalosaurus inhabited what is now North America during the late Cretaceous period, thriving in open plains and forested environments. Its herbivorous diet allowed it to exploit diverse plant life, from low-lying shrubs to small trees. The warm climate and abundant vegetation of the Cretaceous provided an ideal habitat for Pachycephalosaurus and other herbivores. Its bipedal stance likely helped it reach higher vegetation while allowing it to spot predators like Tyrannosaurus rex in its environment. An unusual dinosaur with unique defenses. The thick skull of Pachycephalosaurus has fascinated paleontologists and remains a subject of debate. While headbutting behavior is a popular theory, some scientists argue that the dome may have been used more for display or recognition within its species rather than physical combat. Regardless of its exact function, Pachycephalosaurus stands out as a remarkable example of the diversity and specialization seen in Cretaceous dinosaurs. Its unique adaptations make it a compelling figure in the study of dinosaur behavior and evolution. Prosauropods, the flexible pioneers of the Triassic. Characteristics: bipedal and quadrupedal adaptations. Prosauropods were among the earliest groups of long-necked dinosaurs, acting as precursors to the massive sauropods of later periods. These herbivorous dinosaurs lived during the Triassic period, approximately 230 to 200 million years ago, and displayed a unique mix of traits that reflected their transitional role in dinosaur evolution. One of their most notable characteristics was their ability to walk on both two legs, bipedal, and four legs, quadrupedal. This adaptability allowed them to graze on low vegetation when on all fours and access higher plants when rearing up on their hind legs. Prosauropods had elongated necks, small heads, and teeth that were serrated but relatively simple, making them effective at processing plant material. Despite being primarily herbivorous, fossil evidence suggests they may have occasionally eaten small animals or scavenged opportunistically, indicating a degree of dietary flexibility. Prosauropods typically ranged from 2 to 10 meters in length and weighed up to 1,000 kilograms. Their lightweight frames and strong hind legs made them relatively agile, helping them evade predators in their ecosystems. Habitat: Triassic landscapes. Prosauropods thrived during the late Triassic period in a variety of environments, from arid deserts to forested floodplains. Their fossils have been found on nearly every continent, reflecting their wide geographic distribution during the early Age of Dinosaurs. At the time, the supercontinent Pangaea was still intact, allowing prosauropods to spread across vast landmasses without geographical barriers. The climate of the Triassic was generally warm and dry, supporting a mix of cycads, ferns, and gymnosperms that formed the bulk of the prosauropods' diet. Their long necks allowed them to browse vegetation at various heights, giving them access to a range of food sources in diverse habitats. An evolutionary bridge. Prosauropods played a crucial evolutionary role, bridging the gap between earlier reptiles and the massive sauropods that would dominate the Jurassic period. Notable species include Plateosaurus, a well-known prosauropod from Europe, measuring up to 10 meters in length; Rheogosaurus, a quadrupedal prosauropod from South America, which displayed adaptations for stability and grazing. Their ability to adapt to changing environments and their flexible feeding habits allowed prosauropods to thrive during the Triassic, paving the way for the evolution of larger, more specialized sauropods. Prosauropods represent the early experimentation in dinosaur evolution, combining traits of both early reptiles and their sauropod descendants. Their adaptability and transitional features highlight the dynamic evolutionary processes of the Triassic period, making them key players in the dawn of the Age of Dinosaurs. Ornithopods, the adaptable grazers of the Mesozoic. Characteristics: bipedal and quadrupedal herbivores. Ornithopods were a highly successful group of herbivorous dinosaurs that thrived throughout the Mesozoic era, from the Jurassic to the Cretaceous period. These adaptable dinosaurs had the ability to walk on both two legs, bipedal, and four legs, quadrupedal, depending on their needs. Their strong hind limbs made them efficient runners, while their flexible forelimbs allowed them to browse vegetation closer to the ground when necessary. Known for their specialized teeth and jaws, ornithopods had complex dental batteries that enabled them to grind tough plant material with incredible efficiency. This adaptation allowed them to exploit a variety of plant resources, including ferns, conifers, and the emerging flowering plants of the Cretaceous. Ranging in size from small species like Hypsilophodon at just 2 meters long, to large hadrosaurids like Edmontosaurus, which could grow up to 13 meters, ornithopods exhibited considerable diversity. Their lightweight frames and keen senses made them adept at evading predators. Habitat: widely distributed across continents. Ornithopods were among the most geographically widespread dinosaurs, with fossils discovered on every continent, including Antarctica. This wide distribution reflects their adaptability to diverse climates and environments, from lush forests to arid plains. During the Jurassic, smaller ornithopods like Dryosaurus thrived in forested regions, while in the Cretaceous, larger hadrosaurids or duck-billed dinosaurs dominated open floodplains and coastal areas. Their ability to migrate in herds, as evidenced by fossilized trackways, allowed them to find food and avoid predators in dynamic environments. Key species and adaptations. Hypsilophodon, a small, agile ornithopod from the early Cretaceous, Hypsilophodon relied on speed and agility to escape predators. Its sharp vision and lightweight build made it an expert in foraging and survival. Edmontosaurus. One of the largest ornithopods, Edmontosaurus lived during the late Cretaceous and exhibited herd behavior, as indicated by fossilized bone beds. Its advanced dental structure and broad snout allowed it to graze efficiently on a wide variety of plants. Iguanodon, a mid-sized ornithopod from the early Cretaceous, Iguanodon is famous for its thumb spike, which may have been used for defense or foraging. The social grazers. Ornithopods were highly social dinosaurs, often living and migrating in large herds. This herd behavior provided protection from predators like Tyrannosaurus rex and Allosaurus. Fossil evidence of nesting sites such as those attributed to Maiasaura suggests that some species exhibited parental care, guarding their young and possibly feeding them until they were capable of independence. A lasting legacy. Ornithopods were key players in the ecosystems of the Mesozoic era, shaping plant communities through their grazing and serving as vital links in the food chain. Their adaptability and success across millions of years highlight their importance in dinosaur evolution. As versatile and social herbivores, ornithopods continue to captivate paleontologists and dinosaur enthusiasts alike. Ornithomimus, the ostrich-like dinosaurs. Characteristics: swift and bird-like. Ornithomimus, meaning bird mimic, was a fascinating dinosaur that closely resembled modern ostriches in both appearance and behavior. These theropods were part of the Ornithomimidae family and lived during the late Cretaceous, approximately 70 to 66 million years ago. They were bipedal, fast-running dinosaurs with long legs, a lightweight body and a small, toothless beak, making them well adapted for speed and agility. Growing up to 4 meters in length and weighing around 150 kilograms, Ornithomimus was covered in feathers, as evidenced by fossil impressions. Its wings, though not used for flight, may have been utilized for display or thermoregulation. The presence of gastroliths, stones in the stomach used for grinding food, suggests a diet that included both plants and small animals, making Ornithomimus an omnivore. Its large eyes and keen vision likely helped it detect predators and locate food, while its sharp claws could have been used for foraging or defense. Notable features and behavior. Speed. With its long legs and lightweight build, Ornithomimus was one of the fastest dinosaurs, capable of reaching speeds comparable to modern ostriches, up to 60 kilometers per hour. This speed was likely its primary defense mechanism against predators like Tyrannosaurus rex. Omnivorous diet. Fossil evidence indicates that Ornithomimus had a varied diet. It grazed on plants, fruits, and seeds while also preying on insects and small vertebrates, making it an opportunistic feeder. Feathered body. The discovery of feather impressions on Ornithomimus fossils confirmed that these dinosaurs had a bird-like appearance. Feathers may have served for display during mating or to regulate body temperature. Habitat. Thriving in the Cretaceous world. Ornithomimus lived during the late Cretaceous in regions that are now North America. Its habitat included open plains, forests, and floodplains, environments that supported a variety of plant life and smaller prey. Its omnivorous diet and fast-running ability allowed it to thrive in these diverse ecosystems, avoiding predators while efficiently exploiting available resources. A link to modern birds. As one of the most bird-like dinosaurs, Ornithomimus provides critical insights into the evolutionary connection between non-avian dinosaurs and modern birds. Its body structure, feathers, and beak highlight the gradual adaptations that led to the rise of avian species. Ornithomimus represents the ingenuity of evolution, showcasing how a blend of speed, agility, and dietary flexibility enabled it to survive in the dynamic ecosystems of the late Cretaceous.